Welcome to today's lesson on section 5.2, dividing polynomials. When we divide polynomials, there's a couple different situations that you need to be aware of. One of the situations is when you're dividing by a monomial, or just one single term. When you're dividing something by just a single term, we do it differently than if we're dividing by a couple terms. So keep that in mind. Anytime you're dividing by one term like this, all we're basically doing is we are taking each one of these terms and dividing by that term. It's kind of like saying x over or minus 7 over 2. It's the same as x over 2 minus 7 over 2. You're dividing both terms by 2. Well, in this case, I'm dividing all three of these by 4CDF, and then I am going to simplify each one. All right, so if I simplify the first one, I end up with 20 divided by 4, which is 5. C to the fourth divided by c is c to the third. D squared is divided by d is just d, and then the f's eliminate. The next one, we have a minus 4 c. I'm sorry, the c's cancel, the d's cancel, leaving me with just an f. And here they're both identical, so basically everything eliminates, leaving me with plus 1. Don't forget, if everything eliminates, you don't get 0, you get 1. So this is my simplified form of this polynomial divided by a monomial. All right, the second example, you're multiplying by a monomial, but you're multiplying by that to the negative 1 power, which basically means you're dividing. Okay, so really we're doing exactly the same thing we did up here. They just wrote it a little bit differently. Instead of dividing by this monomial, they're multiplying by the reciprocal. So we're going to basically take each one of these terms and divide by 3xy. When I do that, again, I just simplify. I end up with 6x here. I end up with 9x squared y z. So again, just quick, when you're dividing by a monomial, you divide each term by that monomial. All right, now the next thing is when you are dividing by something that is not a monomial, so like a binomial, excuse me, didn't mean to do that. So we are learning two methods for for dividing by something other than a monomial. Now this one I am just using as a practice to refresh our memories on how to divide using long division. And this is always a fun lesson to do in class because I get to hear all the groans and moans and, I don't remember this and so on and so forth. But today I get to do this without hearing all of that, which actually isn't going to be as fun. Here's an example of what we're leading up to. So here we have a polynomial divided by a binomial. So that means it's different than dividing by a monomial. Okay, now here we have kind of a large number, 2,542,013. I'm going to divide that number by 12, and I'm not going to use a calculator. You can use a calculator to help you find out how many times something goes in, but this one, 12, is pretty simple. I pretty much know all the multiples of 12, so I shouldn't need a calculator at all. Okay, 2, 5, 4, 2, 0, 1, 3, that gets put inside of the division bracket with the 12 on the outside. All right, so when you divide using long division, basically what you do is you look at the outside number and try to decide how many times that number goes into the first number. Well, obviously 12 does not go into 2. So we go on to the next number as well. How many times does 12 go into 25? And there we go. We know that 12 goes into 25 twice. And I put that over the 5 because that's the last number that I'm going into. Okay, so the next step then is to multiply it back times 12. I get 24. And then I subtract that 24 from 25. So that's the process. How many times does 12 go into 25? It goes in there twice. 2 times 12 is 24, but then I subtract it. I take it away, which is 1. The next step, I drop the next number, 4. Okay? Now I do it again. How many times does 12 go into 14? Once. Multiply it back. 12. Subtract. 2. Drop the next number, 2. Okay, we keep doing this until we get to the end. 12 goes into 22 once. 12, subtract 10, drop the 0, that's 100. 12 goes into 100 8 times. You notice that I'm constantly putting the next number over the next digit, or the last digit, okay? So 12 goes in here 8 times, which is 96. 4 is left. Drop the 1. Goes in there 3 times. 36. Subtract. That's 5. Drop the 3. 12 goes into 53 4 times. Now I'm getting to the end here. Goes in there 4 times, which is 48. Which gives me a 5 as a remainder. 12 does not go into 5. Now I could keep going, I could put decimals and keep going. Or I can just put my answer as 5/12 at that point. So my quotient, after I divide this 2,542,000 number by 12, is 211,834 and 5/12. All right, rewatch that if you need to. Practice that. Find a number on your own, practice it. And then you can check your answer always on a calculator to see how close you are and see if you're doing things right. The biggest mistake people make is subtracting wrong. So be careful of that. Now, why are we learning this? Why are we going over this? Is because we're using exactly the same method when dividing polynomials. Okay? So let's go ahead and do this. When I divide a polynomial using long division, I am going to basically use the same method. Okay, so I'm going to put x squared plus 7x minus 30 inside the division sign with x minus 3 on the outside. All right, now we look and see how many times does x minus 3 go into the first 2 terms? Okay, what do I multiply x by to get x squared is basically what I'm asking. What do I multiply x by to get x squared? Well, that's x. Then I multiply it back times the whole thing. I get x squared minus 3x. And the reason I want to make sure, the biggest thing here is I want these to subtract and get 0. I want these to cancel. So when I subtract, make sure you put your parentheses and you put a minus sign with a line. And the reason is because I just said, people make the biggest mistakes with subtracting. So make sure when you subtract, these cancel, but make sure you subtract down here. 7x minus negative 3x is not 4x. A lot of us think it's going to be 4x. No, it's 10x because you're change, right? You're adding the opposite. You're adding 3x. So 7x plus 3x is 10x. I'm going to drop my minus 30. I do the same thing I just did. What do I multiply x by to get 10x, which is obviously plus 10. I have to multiply it back times the whole thing. I get 10x minus 30. When I subtract, I get 0. There is no remainder. When I take this divided by this, my answer is x plus 10. Okay? X plus 10. So, that's what we're doing today. We're doing long division of polynomials. We're using the number part to help us understand and remember the process, but we need to go ahead and be able to do this. Okay? So let's do another one. All right, let me erase this one, and we'll do another one right here. Okay, let's go with 2b. It's in your book. Follow along if you can. Okay, so here we're going to actually try this. If you can, pause the video and try this right now. See if you can do it. See if you can follow along with what they say in the book. Give it a shot. I'll go over it here when you're done. Okay, welcome back. We're going to go over this. X minus 1, x squared minus 13x plus 12. X multiply by another x to get x squared. I multiply it back times the whole thing. I get x squared minus x, and then I'm going to subtract. Change, change. I actually am adding a positive x to negative 13, which is negative 12x. I'm going to drop the plus 12. Multiply x times negative 12 to get this, which actually gives me negative 12x plus 12, which when I subtract, I get 0. You're not always going to get a remainder of 0. That is not always the case. So just be careful of that. I'm going to show you. There's my my quotient, my answer to the division problem. Hopefully that's what you got. Now, let's go over a couple more that are a little more, they're not tricky. It's the same process, just got to be careful of certain things. Number 3 in your book, example 3, is r squared plus 5r plus 7, but this time we're multiplying by 1 minus r to the negative 1. So it's just like that one we did in example 1, where you're multiplying by the reciprocal. This time, we're still going to go ahead and put the r squared plus 5r plus 7 underneath, but instead of dividing by 1 minus r, we're going to put it in standard form. So it's negative r plus 1. Now, you do exactly the same thing. If you've got the process down, it's not a problem. You should just do it. Negative r times what? What do you multiply this by to get r squared? Well, that's negative r. Negative r times negative r is r squared. Negative r times 1 is negative r. When you subtract, again, your change, so you're actually adding 5 plus 1, which is 6r. Drop the plus 7. Negative r times what is 6r, and that's negative 6. That means you get positive 6r minus 6, and here we are getting a remainder because 6r minus 6r is 0, but 7 minus a negative 6 is 13. Again, it's not 1. So many people make that mistake right there. You really have to be careful not to add accidentally. You need to subtract those. Plus, to do a remainder on these, you add the remainder over what you are dividing by, which is either negative r plus 1 or 1 minus r. Either way, it's the same thing. So that's how you illustrate a remainder, because all you're basically doing is still dividing this by this. You just aren't finishing it. You're just writing it as a fraction. All right, one more on long dividing. This is just an extra example I came up with just to give you another different type of a problem. So I'll do just an example here. X cubed minus 3x squared plus 9 divided by x plus 2. Okay, there's something here that you need to pay attention to. Do you notice that this one has a cubic, a quadratic, but it does not have a linear term? It has a constant. So when you put in here into your problem, you need to make sure that you take into account that the missing term. It's missing x. So you put in x cubed minus 3x squared plus 0x plus 9. You need to make sure you account for that missing term. Very, very important. Standard form, starting with the first term, accounting for every term that should be there after that. If it's missing that term, you put it in as a 0 times that variable. If it was missing the x squared, you'd put 0x squared there, okay? Now, we still do the same thing up front. If you're missing something after the first term here, you would have to put that in as 0 as well. We're not. We start with linear. We have a constant. We're done. Do the same thing. What do we multiply x by to get x cubed? That's x squared. Multiply it back times both of them. We get x cubed plus 2x squared, and then we're going to subtract. This time we get negative 3 minus 2 is negative 5x squared. Drop the plus 0x. X times negative 5x gives me negative 5x squared. Negative 5x times 2 is negative 10x. Subtract. Subtract, we get positive 10x. We're going to put the plus 9 down here. X times 10. So 10x plus 20. Subtract, we get negative 11. That is my remainder. So I can either do a plus negative 11 over x plus 2, or we can subtract positive 11 over x plus 2. But there is my quotient. Okay, hopefully that helps. Hopefully you practice that and you're starting to get the right answers. Practice as much as you need to do this and to understand this method. Okay? Good luck. Let me know. I can try to help you. We can go over something on Google Meet if you need help.